In section 1.3, we're going to talk about what are called complex numbers. Complex numbers come from something that we've learned about in the past, which is square roots, and when we actually see a negative number under a square root. Up to this point, we have been very, very careful to not say that there is no solution. We've been very careful to say that it is not a real number that you get when you take the square root of a negative. What we learned in previous math classes is specifically when you have a negative underneath a square root, not a cube root or anything else, just a negative under a regular square root, is that the negative will come out of the inside of the square root as an I symbol. So, you only get I's in your answer if you have a square root with a negative on the inside of the square root. So, for instance, if you take a look at these first couple of examples, we already know how to take the square root of 16. The square root of 16 is 4. But then if we want to pull the negative out of the square root, then that will come out as an I. Same thing for this next one. We know how to take the square root of 49. The square root of 49 is 7. And then to pull the negative outside of the square root, we will bring that out as an I. The I stands for what's called an imaginary unit. We can also play around with this formula, is that when we have a negative or a -1 under a square root that we get out an I. We can also play around with this by squaring both sides of the equation. And what happens when you do this is the square root and the squared cancel out, leaving you with just what was underneath the square root, which was the -1. But on the other side now we have an I squared. So this gives us a whole nother property, that I squared equals -1. So let's record this new formula, that I squared equals -1, and we'll use this off and on throughout this section and throughout the course. So what this means is, just as a couple side examples, let's talk about what an I squared being equal to -1 would mean. An example of this would be something like if I have 8I squared. Then because I squared here is going to get replaced with a -1, what that becomes is an 8 times -1, which is -8. Or another example would be something like if I have -6I squared, again, because the I squared is -1, what that would do is give us that -6 times -1 gives us now a +6. So in a sense, what's going on is whenever we have an I squared attached to a number, it changes the sign. So the positive 8I squared became just the regular number -8. So a -6I squared turned that -6 into just a +6. So what does an I squared do? It basically changes the sign because it gets replaced with a -1. So we'll use this off and on throughout this entire section. Here's another one. We've got another square we can take a look at here, is we've got the square root of -25. Well, we know that the square root of 25 is 5. And we just talked about this. The square root of a negative can come out as an I. And then this piece also had a 4 in front of it that was added to this piece. And so what we end up with is this guy, 4 plus 5I. Those cannot be added because they are not like terms. Just like before, this is a big deal, is we can only add or subtract things that are like terms. What do we mean things that are like terms? Things that have i's can only get added with other things that have i's. Normal numbers can only get added with normal numbers. And so what we'll notice is we're going to see a lot of things that look like this 4 plus 5i. That is what's called your complex number. And the reason why it's called complex is because you've got two parts of your complex number. You've got a real part and an imaginary part. So you get this real part plus an imaginary. And that's what we see right here when you look at things like a plus bi. The real part always comes first. The imaginary part, the I part, always comes second. And what you'll notice is i's will work a lot like x's for the most part, except for we're used to putting x terms at the beginning. We're going to put the I terms at the end. In this next one, we have the square root of negative 81. So let's take a look at these next few problems with this one. So we'll start out with the square root of 81, which we already know is 9. And then we'll bring out the negative from the square root, which will come out as an I. So our final answer for this first problem is just an imaginary number, 9i. The next one, we've got the square root of negative 11. Notice with the 11, we can't take the square root of 11. So we have to leave that inside the square root. However, we can take the negative outside of the square root. That will come out as an I. But the 11, we're stuck with. You can't take the square root of it, so it stays inside. So our answer looks a little bit funny for B here, is it looks like I square roots of 11. But some of our answers are going to look exactly like this. Let's take a look at C. In C, we have I square roots of negative 16. So let's leave that I that's out in front there for a little bit. And let's work on the square root of negative 16. Well, we said that the square root of the 16 is a 4. And the square root where the negative is, that'll come out as an I. So that gives us that we've actually got an I times a 4i, which will get us 4i squared. And we just talked about this a second ago, is that I squared can get replaced with a negative 1. So we'll replace that I squared with a negative 1. So that means I've got 4 times negative 1, which is negative 4, and that's my final answer for C. Taking a look at D, let's take a look. We've got 4 plus square root of negative 5. So the 4, there's nothing we can do with that. Plus, now we can take the square root of just the negative sign. That will come out as an I. However, you cannot take the square root of 5, so that's going to stay inside of our square root. And that's our final answer is 4 plus I square roots of 5. It's not pretty, but that's all you can do is pull out the I. And you cannot add these two pieces because they're not like terms. Let's take a look at one last one, E. In E, we've got negative square root of negative 24. Now be careful. I know a lot of times you want to turn two negatives into a positive. That is not what's going to happen here. So let's deal with one thing at a time. In order to take the square root of 24, we can't take the square root as it is. So the question is, can we break down the 24 into two things, one of which we can take the square root of? And yes, that is possible. I can break down the 24 into 4 times 6. And the question is, why is that helpful? Because I can take the square root of 4, it will come out as a 2. However, the 6 I am stuck with, that's going to have to stay inside of the square root because you cannot take the square root of 6. However, I can pull out the negative that's inside the square root. It will come out as an I. And I also haven't touched this yet, but there was a negative out in front of the square root that's just going to get carried along and make sure that our answer is negative. So here's the problem. The negative on the outside meant that we had a negative answer. The negative on the inside of the root meant that we had an imaginary answer. It didn't mean we had a negative answer. So we're getting our final answer, which is negative 2i square roots of 6. It's not pretty. However, because you're going to be hand keying these into my math lab, you need to be very, very careful typing these in.